Welcome to lesson 4.5 of Tech Math. We're looking at linear, exponential, and simple quadratics. So we're going to look at several different problems. We're going to be able to evaluate those expressions and use those different families. So here's our first situation, braking distance of a car. We've looked at that before. Braking distance is the distance a car travels, but between the time you press the brakes and it actually stops. Okay. So what are some things that might affect braking distance? All right, so speed, how fast you're going, how fast the car is going, maybe speed of reflexes, weight of the vehicle, maybe weight of the cargo if you're towing something, the tire quality, are they good, are they about to be worn down? So lots of different things can go into that, okay? Then you're making a prediction, right? Predicting. So this can be right, wrong, I'll let you guess on that one. Then we're going to use this formula. So this is a formula. It's kind of simplified, but it has the main components. Okay. And then we're going to use that formula from above to answer some questions. So here I've plugged in the values into that formula. Now we have an equation to solve. So I plugged in 0.8, I plugged in 0.05, and you're going to use that to solve. But before we can do that, or in similar questions, we have to do a conversion. So we did this in the prep. We're looking at miles per hour. So in this case, 10 miles per hour, and we have to convert it to feet per second. And then use that in the formula. So let's convert the first one together. 1 hour is 60 minutes. 1 minute is 60 seconds. And then 1 mile is 5,280 feet. So I plug that into my calculator and I get about 14.67 feet per second. Okay, so then in the table, I'm going to write that 14.67, and then I plug in that value for V. And that'll give me D, what I'm trying to solve for. So if V is 14.67, and then divide that by 54.74, actually that's D, not V, and that'll give me my answer. So here we have braking distance, and again you are going to use the chart from above. So now we look at that question that we predicted earlier. What happens to your braking distance, right, if you double the speed? Well, if you double the speed, it's actually going to be four times the amount. And that's because we're squaring things. So if you triple the speed, square that, it's going to be 9 times the amount. So you're going to plot your data from that table, and it's actually going to be a curve. So this curve makes it quadratic, not any of the other points.